Assalamualaikum. My name is Ahmad Mohaimin bin Azhar with matrix number 1912004443. Today, we are going to make a SI report work for cadangan pembinaan Velodrome Nasional Malaysia, Bandar Baru Nilai Negeri Sembilan untuk Tertuan Kementerian Belia dan Sukan. So, power bearing capacity is the ability of power foundation to transmit the load underlying bedrock of stronger soil layer. Plexi software and manual calculation is used to analyze the power bearing capacity. So the purpose is the soil investigation must be undergo to determine the bearing capacity of the soil, its settle rate and the position of the water table. And our objective for this SI test is to analyze the power bearing capacity using the Plexi software, and the last is to study the factor of safety from the result in the power analysis by using Plexi software and Excel sheet.
Hi, I'm Koizeng and I'm from Group B7. Today I'm going to present about the procedure for our geotechnic OEL. First, we need to extract out the relevant parameters of soil based on borehole data. From the SI report, extract and list out the relevant parameters of soil to gather the actual depth of the soil. As the depth of each layer of soil is gathered, compute all the depths to get the overall depth for the borehole pile. Gather the relevant information that needs to be used in a hands-on calculation later. The information that we need is cohesion value for soil, factor of safety, friction angle for medium, and saturation value for soil. Next, we perform the manual calculation of deep foundation. We calculate the pile capacity by using our fast method. Then we obtain the maximum bearing capacity through the equation that is stated below. Finally, we develop a model of deep foundation using Plexi software, which is taught in the tutorial. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azrul bin Ismail. My metric number 191200488. Our point of borehole is BH3 with the equal depth of 15.28 meters. And the SPT blow count or N value achieved 50 at the depth of 9 meters. So we can consider the soil is hard enough to stand the load from above when the N value is equal to 50 or N value achieved 50. There are two types of soil, which is silty clay and sandy silt. And the water level was found at the depth of 3.4 meter. The analysis was done till the depth of 9 meter with the pile type is pan pile, and the diameter of pile is equal to 0.5 meter, and with the depth of every layer of SPT equal to 1.5 meter. We also have the data for skin resistant area, end bearing area, safety factor, and so on. And then from the data, we calculate the skin resistant QS, end bearing QB, and also Q ultimate. And then the result of or the value of Q ultimate together with the soil parameter, we transfer it to the Plexi software. Okay, and after we insert all the pile and soil parameter that needed into the Plexi software, then we can run the analysis. And then from the analysis, we can get the result of the displacement, the stress, and strain value. That's all from me. Thank you.
Now, I will explain about the discussion. So from there, we can determine the soil silt is at a depth of 9 meters based on the data from the SI report in borehole log. We also can detect the deformation soil, total stress, total strain, and other factors involved in a pipe and foundation building using the Plexi software result. And then the pile displacement from the surface that we get is 0.0017218 meters according to our deformed mesh result. Because the sandy silt can support the complete bearing capacity that we put to the pie was not excessively deep. Why? Total strength that we get is negative 0.01883%. The total stress around the pie was at its peak, particularly near to the bottom. The highest value for total stress can be found at the bottom of the pie. The soil above the 1.5 meter from the ground level is not saturated, although the rest of the soil is saturated. The soil is divided into two layers. So the first layer is from 0 to 1.5 meter is a clay, and then the second layer from 1.5 meter to 9 meter is a sand. That's all.
Assalamualaikum and hi, my name is Nur Akida binti Subri and I will talk about conclusion. We conducted a test in the open-end lab to measure the strength of a particular type of soil using a procedure known as deep foundation construction. Through the process, we choose silt and clay for the type of soil as well as different pile depths. As a result, we may conclude that if a pile is deeper in a construction, it can support more load from the structure. Furthermore, various mistakes may occur during driving the piles and designing the borehole, especially in the calculation. In general, the most common errors that occur are random errors since there are many possibilities for the data to obtain, such as the measurement being too large or too little. The best way to reduce mistakes is to conduct multiple trials and get the average result. Besides that, human error is one of the errors that may occur in this experiment as a result of carelessness or human ability limits. We as humans may have recorded the data and measurements incorrectly. Errors can also occur during piling as pipe foundations are related to soil and other hidden elements in the ground. And we cannot expect the experiment to be completely successful because there are various unknown elements in the soil. Errors in deep foundations can have serious consequences in terms of life, construction time, and cost of project. It may also result in questionable data during the process. In the end, the experiment was considered a success since the calculation of the Plexus software output indirectly validated all of the human load calculations. That's all from me. Thank you.